Hello, and thanks for clicking, and welcome to another Anarculus production. Today, we are going to talk about some basic derivative rules. These are derivative rules that are basic. So let's get started, because you guys are going to be way happier about this lesson than you were the last one. I guarantee you that. All right, so let's talk about your limit definition, right? You know how to find the derivative of a function. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. Or you could also use the alternate definition, right? That would find you the value at a point. The limit is x, or f prime of c is equal to the limit as x goes to c of f of x minus f of c over x minus c. Now, that's wonderful, but what if you had to find the derivative of this? Okay, no one has any desire to use either of these definitions to come up with the actual derivative of this function. So, the one thing we love to do in math is to teach you something that's really complicated and make you do it in a really difficult way, and then say, oh yeah, by the way, we could have done it like this, and this is way easier. All right. So today is that day. Today we are going to do it. Okay. But again, just so you know, the AP exam will ask you these definitions, and in some ways, not necessarily the way that you think that they will ask it to you. Okay. So you do need to know these definitions. These are not something you can just take and throw in the garbage now that you're learning how to do it the fast way. All right. Okay. So let's start talking about how to do some of these rules. So here's a small little exploration here, which hopefully will bring some meaning to this. Okay, in the left-hand column of this chart are all functions, f of x. Okay, f of x is x squared, x cubed, x to the fourth, x to the fifth, x to the sixth. On the right is the derivative of each one. So if I use the limit definition, limit as h goes to 0, f of x plus h minus f of x over h. For example, if I use it on f of x equals x squared, I'll get 2x when I'm done. Okay, if I use it on x cubed, I'll get 3x squared. If I use it on x to the fourth, I'll get 4x cubed. So now the question is, what's the pattern? Can you tell me what the pattern is for me to start with f of x? So for example, if I were to say to you, f of x is x to the 9, x to the 9th power. What is the derivative of x to the 9th? Okay, using what you've learned here. All right, using what you've learned here. Okay, all right, maybe I'll pose that question to you and see how you do on it. Can you tell me what the answer is? All right, let's keep going. So what you should have found is, in that pattern, is you should have found what we call the power rule. Okay, the power rule just says that if you have x, or a variable raised to a numeric power, you can find the derivative by taking the numeric power, putting it in the front, and taking 1 from the power. Okay, take the power, put it in the front, and subtract 1 from the power. Right? So, for example, when we had x cubed, f of x is x cubed, its derivative is just, well, take the 3, put it in the front, take 1 from the power, and you get 3x squared. That's the answer I told you it was. Okay, this is called the power rule. It's the most basic, pretty much the most basic of the rules that we're going to learn this year. All right, so let's see what we can do. Let's try some power rule problems. Here we go. Okay, here's some practice coming up. So I want you to derive with respect to x to the 5th. Okay, derive x to the 5th. So take this numeric power, put it in the front, take 1 from the power, you get 5x to the 4th. You're all done. How about this one underneath? X to the 3 halves. Variable to a numeric power, take the numeric power, put it in the front, and subtract 1 from the power. So I'm going to get 3 halves x to the 1 half. There's my derivative. Okay, this is the derivative. Without the limit as h goes to 0 of f of x plus h minus f of x over h. Okay, no need for that. All right, how about this? F of x is the 7th root of x. Find f prime. Okay, there's one thing you have to really understand about the rules that I'm showing you today. All right, I showed you earlier that the derivative with respect to x of x to the n is equal to nx to the n minus 1, right? That's the power rule. Okay, now this is a very basic, a very simple rule. So to use the rule, you have to be in this form. If you're not in this form, the rule doesn't work. Okay, so that means the first thing I'd have to do here really is I'd really have to change f of x into x to the 1/7 power, right? That means the 7th root. Okay, now I can use the power rule. So f prime is just 1/7 x to the, well, take 1 from the power, and you get 1/7 x to the minus 6/7. And you can bring x to the negative 6/7 down to the bottom because it's a negative exponent, and you'll have 1 over 7 x to the 6/7 power. And there's your answer. You don't have to go back to the radical notation that you started with. You can leave it in fractional notation if you want, rational notation. Okay, same thing here, right? So this problem says y equals 1 over x to the 6th. Find dy dx. So this is Leibniz notation, right? Okay, find dy dx. I haven't seen a lot of that, but we're going to start seeing more of it. All right, but again, we're in the same scenario. The rule that we've been provided shows us x being in the numerator. Okay, so this is x to the n. This is in the numerator. It doesn't show you anything about a denominator, right? So if you want to derive this, the first thing you have to do is take x to the 6th and bring it into the numerator and make it x to the minus 6. Now you can find the derivative of it. Okay, so dy dx, the derivative of y with respect to x, and we're going to talk a lot about notation here coming up also, okay, is equal to, bring the negative 6 down, leave the x, take 1 from the power, and you'll have negative 6 x to the negative 7, or negative 6 over x to the 7. Okay, the negative 6 stays in the numerator, right? It does not belong to the x to the negative 7. X to the negative 7 comes to the denominator. All right, and here's another one. He also uses the power rule. F of x equals x, although it's a little different looking. Okay, to start, I want you to find f prime. Now remember, there's no exponent up here, but there is. There's a 1, but we never write it. Okay, so then the derivative of this is 1. Bring down the 1, leave the x, take 1 from the power, and you'll have x to the 0. But x to the 0 is 1. Okay? So in some cases, you do have some teachers say that there's another rule, but really it's just a power rule problem. But that rule would say the derivative of x itself is equal to 1. Okay? The derivative of x is 1. All right? Okay, let's keep going. These go pretty quick. So here we go. All right, so this is a little bit different now. This is not what we started with originally, right? So now I'm asking you to derive 4x cubed. Okay, 4x cubed. Well, on the last page, I just asked you to derive x cubed, right? Okay, that's the power rule. That's easy to do. Just bring the 3 down, leave the x there, and take 1 from the power. But now, what do we do with this 4 that's in front? Okay, how does that change things? I imagine you're looking at this saying, I really hope I can just leave the 4 out of it and just use the power rule on x cubed. And I'm here to tell you, thankfully, you can. So to derive 4x cubed, leave the 4 there and just derive x cubed with the power rule. Bring the 3 down, leave the x, take 1 from the power, and now you can multiply 4 and 3, you get 12x squared. There's your derivative. Same thing here, okay? Just leave the 3 out of it, bring the 1/2 down, leave the x, take 1 from the power, you'll have negative 1/2, and then the x to the negative 1/2 can go on the bottom. The 3 is on the top. The 2 will come to the bottom, to the denominator. The x to the negative 1/2 will come to the denominator. And you'll have 3 over 2x to the 1/2 power. Okay, there's your answer. All right, that rule has a name as well. Okay, it's called the constant multiple rule. So the constant multiple rule says if you have a number in front of, so here it's written just in terms of the power rule, but it doesn't really matter. If you have some function where you want to derive with respect to x, c times some function f of x, its derivative is c times f prime x. You can just leave the number in front, don't touch it, just leave it there, and derive the part with the expression that has the x in it, the variable. Okay, c is a number. All right, c can't be a variable, c is a number. Okay, all right, let's keep going. See what else we have in store. Okay, here's the constant rule. The derivative of a number is 0. Okay, always. The derivative of a number is 0. All right. So if you have an equation like y equals 2, right, what you really have is this line. We agree? Y equals 2. Okay, so now if I want to find the derivative, I want to find the slope of the tangent line to this line. The slope of the tangent line for this line. Well, if I want to do that, right, I mean, I'll put a point here. Where do I draw the tangent line? Well, the tangent line is, well, there, right? That's the tangent line. Okay, that line that passes through this point and moves in the same direction as the curve. It's there. So the slope of that is also 0. Okay, the slope of that line is 0 as well. All right, so the derivative of any constant is 0. Okay, all right, let's keep going. All right, here we go. Let's make it a little more interesting now. Now I want you to derive for me x cubed plus 4x plus 5. Okay, so now I imagine most of you are looking at this saying, okay, well, that would be the power rule, x cubed, right? And then the derivative of 4x, I could figure that out. And then the derivative of 5 is going to be a 0, right? Because it's just a number by itself. But the fact that they're added, we haven't done anything where they're added yet. So I guess what you're probably hoping is, well, I can just derive each one of these separately and stick plus signs in the middle. And you can. That is a rule. So the derivative of each one individually, the derivative of x cubed is 3x squared. The derivative of 4x, leave the 4 out of it, and the derivative of x is 1. And then the derivative of 5 is 0. Okay, so we have 3x squared plus 4. That's our derivative. All right? Okay, that is valid. We're now using the sum and difference rules. Okay, all right, let's go to the next one. Negative x squared. All right, so that's really a negative 1 in the front there. So leave the negative out of it. The derivative of x squared is a 2. Bring the 2 down, take 1 from the power, x. The derivative of 1,000 is nothing. It's just a number by itself. It's a constant. So my derivative is negative 2x. Okay, let's look at this. F of x is 5x squared minus x plus 7. Find f prime of x, and then find f prime of 4. So let's find f prime of x first. So f prime of x, okay, find the derivative. All right, so I just do them separate. Leave the 5 out of it. Bring the 2 down. Take 1 from the power. Minus, the derivative of x is a 1. The derivative of 7 is nothing. So I have, So I have 10x minus 1. There's my derivative, f prime. So now I want you to find for me f prime of 4. Okay, find for me f prime of 4. So now I want you to take f prime and replace x with 4. So that's 10 times 4 minus 1. That's 39. Okay, that's 39. what does this 39 represent in this problem? What does this 39 represent, okay, in this problem? Now, I'm going to answer it for you, but I do want to give you a second to think about it because I do want you to understand what this is. So this 39, what is it? It is the slope of the tangent line, okay, to f of x equals 5x squared minus x plus 7 at x equals 4, right? So the slope of the tangent line to f of x equals 5x squared minus x plus 7 at x equals 4 is 39. That's what we are doing. That's what the derivative represents. It represents the slope of a tangent line at a specific point, okay, at a specific value. All right, so if I had that curve up, 5x squared minus x plus 7, and this is, well, whatever that curve is, it's a parabola that opens up. I know that. Okay, so whatever. Looks like that. Okay, if this were my coordinate plane, this is not the actual graph, by the way, but it gives you an idea. And I were at x equals 4, and I put a point there. I wanted to find the slope of the tangent line at this point. I just did find the slope of the tangent line at this point. The slope of the tangent line at this point is 39. Okay? That's what you're finding here. That's what this is all about. All right? You have to understand what you're doing. You can't just do. Okay? You can't just use the power rule and say, okay, I know how to use the power rule. What is it that you're getting? What is this all about? All right, so here's your sum and difference rules. We just used them a minute ago, okay? If you add two functions are added or subtracted, you can find the derivatives of each one, okay, separately, and add and subtract them. All right, there's your sum and difference rules. Okay, all right, let's keep going. Okay, so back to some stuff that may require some extra steps. Same thing with the power rule. So the power rule, like I said, is not, you can't necessarily use it just for the sake of using it. The rule says this, right? That's the rule, okay? If it does not look like this, a variable to a power, you cannot use the rule until it looks like that. So, for example, f of x is x times the quantity x plus 4. Distribute the x. You would get x squared plus 4x. Now you can use the power rule on it. F prime is 2x plus 4. Over here, f of x is equal to 3x to the fourth minus 2x squared plus 5x over x. There's a couple ways you can handle this. You could put x underneath all three of them. Some people like to do that. And just write 3x cubed minus 2x plus 5, okay? Or what you could do, which some people do, is they bring the x to the numerator that's in the denominator, make it x to the negative 1, and then distribute it to all three of these. You'll get the same thing either way. You'll get a new f of x, which is 3x cubed minus 2x plus 5. But I want you to derive it. So the derivative of that is going to be 9x squared minus 2. The derivative of 5 is nothing, right? The derivative of x is a 1. I just leave the negative 2 out of it. And here I'm leaving the 3 out of it, bringing the 3 down, taking 1 from the power, and then the 3 times 3 is 9. Okay? Down here, same thing. This kind of looks like it. It is something to a power, but it's not x to the power. Okay? I mean, like I said, we are at the most basic rules that you could be at. If it doesn't say x to the power, you can't use the power rule. So this, you can't use the power rule. This would have to be multiplied out first before you can use the power rule. Okay, so f of x would be x to the fourth minus 4x squared plus 4. So So I'll do it up here. So f prime is 4x cubed minus 8x plus 0, right? Derivative of 4 is nothing. So there's my answer for that one. And finally here, okay, you can leave the 4 up there, but this third root of x has to come to the numerator and become x to the minus 1/3. Okay, x to the minus 1/3. Now you can derive it. All right, so I need you folks to understand that this is not, you can't just derive whatever you want. The rule looks good, so I'm going to use the rule on it. The rule only applies when you're in the form for the rule. If you're not in that form, you can't use it. All right, so this, if I clean it up, I'll do it up here real quick. So you get f prime is equal to negative 4 over 3 x to the 4/3. There's your derivative for the last one. Okay? All right, so I'm going pretty quick, but this is something that I feel like I can go pretty quick on. Okay, so derivatives at a point, real quick. If I ask you to find f prime of 2, all right, ask you what the derivative is at x equals negative 2, you must find the derivative first and then plug in the number. So if I gave you f of x is x squared and I said find f prime of 5, you must find the derivative first, then plug in the number. It's a 10. It's not a negative 10. Whoops, now it's a nothing. Okay, so, and then plug in the number afterwards. You get 10. So what is this telling me? It's telling me the slope of the tangent line on x squared at x equals 5, it's 10. This is the slope of the tangent line. Okay, and again, what would happen if you substituted that x value first in f of x, then tried to take the derivative? What would happen would be, this course would be really easy because the answer would always be 0, right? Every time. Because if you take 5, put it in here, and find the derivative, the answer is 0 because the derivative of a number is 0. Okay? So when you want to find the derivative at a point, you need to find the derivative first in terms of x with respect to x, then plug the number in. That is a common mistake at the beginning. Don't be the person to make it. All right, let's make it a little more interesting. Write the equation of the tangent line to the curve f of x equals the 4th root of x cubed at x equals 16. I want the equation of the tangent line. So to write the equation of a tangent line, I need 2 things. Okay? I need a point and I need a slope. Right? Oops. Let's say the slope. I need the slope of the tangent line. And I need a point to work with. All right? So let's first clean this up a little bit, because you can't derive anything unless you clean this up, right? Because we want to find the slope of the tangent line. To find the slope of the tangent line, you find the derivative. So f of x is equal to x cubed to the 1/4, right? Now again, I cannot derive it like this. The power rule says you can derive a variable to a numeric power, not a variable to a numeric power to a numeric power. So I can multiply these powers together. I'll have x to the 3/4. Now I can derive it. So f prime of x is 3/4 x to the minus 1/4. So I can bring that to the bottom. 3 over 4 x to the 1/4. Okay. So now what do I want to do? I want to evaluate this at 16, right? This will get me the slope of the tangent line. So the slope of the tangent line is f prime of 16, which is going to be 3 over 4 times 16 to the 1/4 power, or the 4th root of 16. The 4th root of 16 is 2. Okay, so that's 3 over 4 times 2, it's 3 over 8. So the slope of the tangent line is 3/8. Now I also need a point to work with. A point has an x and a y. Let me come over here. Okay, so the x value is easy. It's 16. The question is, what's the y value? Well, I need to know the y value on the function f of x, right? If I have this curve, whatever it is, I erased the whole thing. Good thing I remember it. So the slope of the tangent line is 3/8. I know you folks are laughing at me. I'm sure you're laughing at me. I get it. Yeah. Ha ha ha. Yep. Funny. I'm the one who writes the quizzes, you know. Okay, well, anyway, here's a point at 16 comma something. The slope of the tangent line is 3/8, right? That was the derivative evaluated at 16. Okay, and we know f of x is equal to x to the 3/4, and f prime of x was equal to 3/4x to the 1/4, right? All right, so my point a minute ago, before I erased everything and had to write it all back on, was if I had a curve, whatever it may be, call it f of x, and I want a point to work with, I could pick this point here and call it, let's say, 16, for example. Here's my tangent line. Now, the nice part about this is that, remember, the line and this point, okay, the line and the curve share the point in common, right? We talked about that. The line and the curve both share this point in common. It's called the point of tangency. So if I need a y value for the 16, I can just take the 16 and plug it into f of x, and it should give me a y value for it. So f of 16 is 16 to the 3/4. So now if you remember, you can either do this as the 4th root of 16 cubed, or you can do it as 16 cubed to the 1/4. Okay, so the 4th root of 16 is 2. 2 cubed is 8. This I have no desire to do. I'm not able to use a calculator on it, so forget it. I'm not doing that. So there's a point at 16 comma 8. Now I have a point and I have a slope. So now I have point slope. So I can just write y minus 8 equals 3/8 x minus 16. There's the equation of my tangent line. Okay? You don't have to do any more to this. You don't have to find b. Okay? This is the equation of a line and point slope. That's why I'm telling you need to know point slope. All right? Same thing here. F of x is equal to 3x squared minus 2x plus 1. Find f prime of 4. Here we go. F prime of x, 6x minus 2. The derivative of 1 is nothing. Don't need it. Now I'm going to plug 4 in. Okay, find the derivative first, then plug the value in. 6 times 4 minus 2 is 22. I know that the slope of the tangent line, okay, at x equals 4 on this graph is 22. That's what this value represents. You have to understand that. It's a really important component of the basic derivatives. Okay? All right, now I'm going to erase this page for real because I'm going on to the next page. Oh, I didn't erase it. Oh boy, I'm having trouble. All right, here's some trig derivative rules for you to enjoy. Okay, if f of x is equal to sine x, then its derivative is cosine x. If f is cosine x, then its derivative is negative sine x. Okay, you will see these rules. All right, I will prove to you that these rules are true. Not now, but when you least expect it. I will prove that these rules are true. Okay? All right, let's keep going. Here we go. Find the derivative of y equals 4x to the 6th. Here we go. All right, so this is Leibniz notation. So I'm going to write dy over dx. The derivative of y with respect to x is equal to, bring the 6 down. I'm going to get 24x to the 5th. The derivative of x is 1. Plus the derivative is 3 sine x. Leave the 3 out of it. The derivative of sine x is just cosine x. You literally replace sine x with cosine x. Minus 2, the derivative of cosine x is minus sine x. And you're going to have 24x to the 5th minus 1 plus 3 cosine x plus 2 sine x. And that is your derivative with respect to x. And there's your answer. Okay, you're all done. All right. So these are some basic derivative rules. I think that's it. It is. These are some basic derivative rules for you to work on. Okay. Hopefully you did well on the problems as you went along. And that's it for today. Thanks for clicking. Great work.